Yeah. All right, so yesterday we did number 1 together. Any questions on that one? Yes. Can we do number 1? Were you not in here for that? Okay, so, you know, the deal is you guys are supposed to be getting to a point where you're doing this on your own, right? And I know that this is review, and so we haven't seen some of this stuff for a while. So some of this might be a little bit rusty, could be some cobwebs. But the key word here in problem number 1 is decreasing.
I don't even remember how to do this.
And when you see the word decreasing, you should think, did it not work?
You wrote back.
No. Is math more important than history? Okay, anyway, so the key word there is decreasing. Okay? You guys remember what's that? Not necessarily. Okay? Like right now your GPA is decreasing because of that answer, but it's still positive. It just means it's going down. Okay? True. That should hopefully make you think first derivative tests. Okay? Increasing, decreasing was first derivative test. Concave up, concave down was the second derivative test. Okay? So when you see decreasing, not necessarily maybe today, because like Matthew said, it's been a while, you should pretty quickly get to the point where you think first derivative test. What has to be true about the first derivative for the graph to be decreasing? Has to be negative. So since they give us conveniently the derivative, all that means is that the natural log of x minus 2 has to be negative. Okay, so solve that. Just anyone go ahead. E both sides. Okay, so if you E both sides, the natural log cancels. So x minus 2 has to be less than e to the 0, which is 1. You add 2 to both sides and you get x is greater than 3. Okay, or it's less than 3. Sorry, thank you. Okay, but there's another issue here, and that is that you cannot take the natural log of a negative number. So x minus 2 also has to be positive. Okay, so how do you solve that? Add 2 to both sides. And so x has to be greater than 2, but also less than 3, which is answer choice A.
Oh yeah.
All right? Okay, now, was that a big deal?
Yeah.
No, that's not a big deal, right? One little thing, you just had to remember that this had to be negative, and as soon as you did that, you guys were golden. Okay? AP calculus, so easy. All right, number 2. We've got y equals x cosine of x, and our key words in this problem are slope. And when you see the word slope, you think
First derivative.
derivative. Yeah, the derivative, and that's when you were in 8th grade. And in this class, when you see the word slope, you should be thinking derivative.
Basically just sign my life.
No, you didn't.
Yeah.
Okay, so we have to take the derivative of x cosine x.
1 cosine x plus.
Okay, so you want the derivative of the first, which is 1,
Cosine.
and the second, which is cosine of x, plus the derivative of the second, which is negative sine, times the first one, which is x. Okay, so hopefully you guys can come up with that derivative all by yourself, without Ben's help. Is that true? Yes? Product rule? Okay? And I really am mad at Miss Fowler because she taught you that product rule and she did it backwards than I've ever done it. I always do first one times the derivative of the second plus the second one times the derivative of the first, so then you guys always do it backwards and it makes my brain hurt, but you know.
How is
Okay?
Miss Fowler?
No idea.
Do something for his feet about the woods.
Yeah, she's been doing some sewing. Yeah. Okay, so the slope equals 0, so what do I have to do with this? Set it equal to 0.
Oh yeah. Add x under x.
Okay, and then this is the bad thing about the AP calculus test is that it is a test of calculus and trig and geometry and, you know, algebra and da-da-da-da. So the calculus part we're done with. And now we're in like solving a trig equation. What did you say you want to do? Add x sine of x to both sides.
Divide by sine.
Divide by sine of x because we're trying to get the,
That's definitely
so that cancels out. So x equals cosine over sine, which is definitely cotangent. Is that one of our choices?
No.
No?
1 over x equals tangent of x.
Right, okay, so x equaling cotangent of x is not one of the multiple choice thingies, but they also want you to know that cotangent and tangent are inverses. So this would be the same as saying 1 over x equals the tangent of x. So that is, there's a choice B.
Why would you find 1 over x?
Because it's a multiple choice. If you had to book out.
Yeah, so
And x equals cotangent of x is not one of the choices. Okay? So Matthew's brain went and looked at the answers and said, well, we don't have x equals
Oh, okay.
cotangent of x, but we do have 1 over x equals tangent of x, and that's the same thing. Okay? All right, number 3. So we got a big old function f. We got a graph. We're going to find f prime of 1. So what do? Take the derivative of f of x. So we got this funky notation here, but all we're doing is chain rule. What's that? So we're going to go outside in. So what's the derivative of g? G prime. And remember, so we take derivatives, and since we're taking the derivative of g, we leave this stuff in here alone. So you keep that as x plus g of x. And then what do you multiply that by? Derivative of the inside stuff. So we're going outside in. So the derivative of x is 1. No. Plus the derivative of g of x is... No, because if you wanted to try and think about it that way, then if you put the 1 in front, then you subtract 1 and get 0, and then you wouldn't have anything. Alright? Okay, so that's f prime of x. So to figure out what f prime of 1 is, plug in 1 where all the x's are. So that means it's going to be g prime of 1 plus g of 1 times 1 plus g prime of 1. Okay, so we're going, crap, I just threw away 13. Okay, so g prime of, what did you say? G of 1 is 3? Yeah, so if you look at the graph, if you go over to 1 and up to the graph, that means g of 1 is 3. You guys see that? Yeah? Okay, times 1 plus, what's g prime of 1? Close. Farther. Now you're just guessing. What is g closer? What is the derivative? What is g prime? What does that mean physically? Last problem, the slope. So what's the slope of the graph at 1? 4. 1/2. 2. Negative 2. Okay? Negative 2. Alright, so if you go to 1 and you go up to the line, you see that it's down 2 over 1, so that has a slope of negative 2. That's the graph, yeah. No, G. Okay? Alright, so 1 plus 3 obviously is 4, so this all translates into g prime of 4 times negative 1. What is the slope of the graph at 4?
Still looking for my
Really?
calculator.
Rise over run, gentlemen and ladies.
Oh, that's 2.
Rise over run.
Yeah, I said that earlier.
2/3. Okay, that little straight line there, if you go from one corner to another corner, it went up 2 over 3. So g prime of 4 is 2/3
You made fun of me.
times -1 is -2/3, which is answer choice qua. What?
Stacy.
Which one is that? E?
I was just looking for my calculator.
-2/3, yeah. Because we have to multiply that by this jump right here, which came up to be -1. Okay?
Did someone steal Stacy's calculator?
Did someone steal Stacy's calculator up here? So yeah, your pink one? Yeah, I don't know.
There's a lot of that going around.
Probably should. Probably
Probably should. Calculator, Steve.
Yeah, most likely
Only
because
pink one. Okay? Alright, you guys good with that?
Getting stronger.
Glad to hear it. Okay, number 4.
Take the derivative of that, dude.
Antiderivative.
plug it in your calculator.
Okay, except no calculator section. Oh, really? Yeah. Not difficult though. Antiderivative of 1 over x. Natural log of x. Antiderivative of 2x.
Or 2x
Finding me just a go.
cubed.
X squared.
Squared.
Plain old x squared.
Hooligan.
Okay? Plain old x squared. Derivative of x squared is 2x. Okay, plug 6 in. So that gives me natural log of 6 plus 36. Minus, plug 2 in. Natural log of 2 plus 4, right? That's the natural log of 6 minus the natural log of 2.
Natural log of 4.
Close, natural log of 3. You divide when you're
Oh,
subtracting.
yeah,
Okay?
that's right.
Like I said, it's a test of what's that? No calculator. So is that one of our answer choices?
Yes.
Is it?
C.
Oh, yeah.
Can't do it.
C.
Can't
What's
do
the
it.
question, Benjamin?
ln 6 plus 6 is not 1, 2.
Uh-huh. Well, I can't simplify it. So instead, I distributed this negative here to get rid of the parentheses and then combine the natural log of 6 and the natural log of 2. Okay, what?
Oh, nothing.
Okay, say hi to Olivia.
What did you say?
Say hi to Linnea. No, Halen, because you're sitting right by the microphone.
Oh.
Yeah, I was gonna say, when I watch these, which is very rare, I can't ever hear what we're saying.
You
I
guys.
hear what you're saying.
Yeah, the microphone is in the laptop somewhere.
Oh, really?
Yeah.
Not really.
All right,
Linnea.
let's see. 20,
Wait.
15. Okay, see if we can
Can't
get
let it out.
4 more in, and then we'll call it a quarter.
Way too much.
All right, a relative maximum of the function. What is that relative maximum?
Set it to 0.
Yeah, to set what to 0?
Good stuff.
The derivative. Okay, so take the derivative and set it equal to 0. So,
Quotient rule.
quotient rule,
Oh, is that?
Low, high.
low, be high. So the derivative of this, I have to do power rule first. 2 ln of x, and then that would be to the first power, but who cares? Good, time for derivative of that, which is 1 over x. Good, so that's low d high minus,
D low.
okay, which would just be 1.
Square.
Over x squared.
What's below.
Okay,
Set that equal to 0.
set that equal to 0.
Set equal to 0.
All right, so when we're setting this equal to 0, do we care about what's going on with the bottom? No. So this, nobody cares about. Then the 1x and the x will cancel. So we have 2 natural log of x minus natural log of x squared equals 0. Love it! Factor out a natural log of x. So that leaves me 2 minus natural log of x equals 0. So either this part right here has to equal 0, or this part right here has to equal 0. Okay? Can the natural log of x ever equal 0?
No.
No.
Oh, no.
Because this is saying e to the 0 whatever. You can't ever do that. So that's out. So that means the natural log of x must equal 2. Okay? How do we solve that? You e both sides. So those cancel. So x equals e squared. Is that one of our answers?
Sure is.
Show us it is. E.
If we do better on this test, we can work it through.
I'm 100% sure that you're correct. Okay, did not see a Riemann sum coming. Will not get through 4 more problems.
Nobody knows what that is.
Okay, count squares.
Oh, good Lord.
Count squares.
Holy moly.
Do we grab paper on this?
Yeah, you can have scratch paper, I believe. Okay, so we need to come up with the graph of the absolute value of 2x minus 3. What do you think about that? You want to just plug in some numbers? Okay, well, let's figure out first of all where it hits the x-axis. We will not be finding any derivatives. 1.5, yeah, do you guys see if I plug in 1.5, then I'm going to get 0? So that means that it crosses or hits the x-axis right here at 1.5. Okay? Then what do you get? Let's plug in some numbers on either side of that. What do you get if you plug in 2? 1. And what if you plug in 1? What do you get?
Which is 1.
1. Okay, so do you see the shape of the graph here? If I plug in 2, then, I'm sorry, I've already plugged in 2. If I plug in 3, you would get 3. 1, 2, 3. So it's our old friend, same thing if I plug in 0, I'm also going to get 3. It's our old friend, absolute value is the V-shaped graph. Okay? And so they want us to find, oh, so we need to be a little bit careful. Yeah, that's not so good, is it? But I'm all right. I went over 1, up 2, over 1, up 2. So I need to find the area from there to up 2, over 1, up 2, over 1. Where's the, to what? 3? 1, 2, 3. All right, so they're right there. Okay? So they want us to use a right-hand Riemann sum with 4 equal subintervals. So 1, 2, 3, 4. Okay? And I'm going right hand. So that means this is going to be 1 rectangle because I drew it to the right hand side of the subinterval. Okay? Make something here off. Okay. No, I'm okay with that. And then the right hand side of this subinterval, my rectangle is going to look like this. Okay? And then if this one I go to the right hand side and go up, it's going to be a little rectangle that looks like this. And this one I go to the right hand side and go up, it's going to look like that. Okay? Count some squares.
1, 2,
I feel like that you're
8.
7.
I just feel like that does not happen.
Okay? Which is
5.
You seriously looked at that 4 times.
I looked at you 4 times and I know.
That was not bad for you.
Okay. Is that a little bit, is that a little wacky there, a little too much? Is that okay?
Wait on that.
You got it? Okay, you understand the right hand interval, what that means? Is to go to the right of this and draw up to the graph? Okay? You guys all right?
Just the right one.
Oh, yeah.
Okay.
No,
And
you
that's
have
called
to
the
use-
Riemann sum. So
Plug in.
Riemann rectangle. Riemann
Just
rectangle.
plug in numbers for the graph.
Yeah, I mean, if you look at the now that we have the graph, 2x minus 3, this right here is the slope. So from this point, or from here, we're going up 2, over 1, up 2, over 1, okay? And then you just have to find the x-intercept, you know. Okay, all right, one more. Uno más. Uno mas. Okay, number 7, an equation of the line tangent to the graph. Y equals x cubed plus 3x squared plus 2 at its point of inflection is. So point of inflection, keyword, says to you, second derivative. Very nice. So first derivative is,
3x squared plus 6x.
okay, second derivative is,
6x plus 6.
okay, what do I do with my second derivative to find the point of inflection? Set it equal to 0. So 6x plus 6 equals 0 means x equals, all right? So that's the x value. Plug it into what? I got 3.
The original.
The original one. Does this mean you guys are actually learning this year?
Oh, yeah, it does.
Even while you were
Exactly.
When it's
Don't underestimate our power.
They chance
slapping and
No.
talking about Walking Dead and okay, -1 to the third is -1. What this is going to be 3 plus 2, so that's 4. So my point of inflection is y equals x equals -1, y equals 4. So I'm trying to come up with an equation. There's the point. What else do I need for an equation? How do I find the slope? Plug it into the first derivative, right? The first derivative is the equation for the slope of this graph at any point. Okay, so if I take -1 and plug it into there, you get 3 minus 6 is -3. So there's my point. There's the slope.
Y
What?
minus 4 equals -3 x plus 1.
Okay, those are solved for y, right? So -3x minus 3, add 4, y equals -3x plus 1, which is
A for apple.
A for awesome.
A for awesome, A for all done, A for, okay, do this over break.
Yeah, but
Okay? No, but like if you could get as far as you can in exam 1, that would be totally awesome.
I gotta read the
And
whole
you will
book.
benefit more from this activity that we're doing together if you have tried the problems on your own and already thought about them a little bit, than if you just sit there and listen to Matthew give all the answers.